would like to introduce our next speaker, whose presentation is Connecting 500,000 Hosts. Vanna, would you please help David Tatlisu come on down, or come on up? David will be presenting Connecting 500,000 Hosts. He's a backbone network engineer at IONOS SE. This is his first time presenting at NANOG, and it is a pleasure to have him. Good luck. You're going to need it.
Yeah, hi everyone. I'm usually a pretty introverted person, so please be kind. With this talk, I try to go against the corporate, hey, everything works great all the time stigma and talk about stuff that doesn't go well. So public relations requested that I put the following slide at the beginning. So this is IONOS. It's a pretty big player in Europe, and yeah, we exist. And yeah, the fundamentals of our network are basically that we've got a dual vendor strategy. We've got basically a complete Cisco and Juniper backbone in case something hits the fan and one of our vendors fails. We're running MACSEC everywhere, which will introduce some interesting problems, and we've got five different setups. So since we're doing dual vendor, we've got a Juniper and Cisco POP in small and big sizes, and a data center handover setup, which is replicated to each data center. Starting with the ugly stuff, I've got this fun picture. So you'll see the green symbol on the left that indicates Juniper routers in all following diagrams. We're using this specific hardware. And for the Cisco side, we're using this blue symbol. And yeah. For our DWM equipment, right now we're just using Adva SFP 3000 and Infinera Groove. I'm not encouraging you to buy them, but I'm just telling you this is what we use, and this is what I'm going to talk about later in this talk. So the actual network topology is fairly simple. We're using segment routing with MPLS with IS-IS as our IGP everywhere. It's a fairly standard setup with latency-based metrics, just so traffic exits the network the quickest way possible. We're using unnumbered interfaces on most links, not everywhere, because there's an interrupt bug we're going to talk about. And of course, we've got dual stack everywhere because IPv6 is the future, has been the future for the last 20 years. And we try to enable all of our downstreams to migrate or use IPv6. So with modern router hardware, it's not really a huge problem to run IBGP full mesh in the backbone. With modern platforms easily handling 50 million routes in the routing table, this scales fairly well. We've also got some route reflector sessions for EVPN services, which we're going to talk about later. And something quite unusual is that we've got next hop policies applied. So since next hop policies are kind of unheard of or not as popular as I'd like them to be, this is just a quick reminder. If we have this example topology looking at the routing table from the central router, the 201db8:2, we can see that the path through router 1 to AS65000 is the best one because the AS path is the shortest. And if we now have a router failure, its loopback IP is removed from the IS-IS database, which will then cause the other routers to resolve the BGP next hop through the aggregate route, which will eventually lead to a discard. So this would cause a partial network outage because BGP doesn't need to converge because the session is up, the routing table information is still up to date. The next hop is still resolvable, even be it through the discard route. And this is going to cause a bit of an incident. So what you can do is basically apply next hop policy to your routers that forbid using the aggregate routes or whatever route you don't want to use for resolving next hops, which will then cause the routing table to look like this. So now the path through db8:1 is immediately rendered unusable. This is a bit nicer than when using BFD, where you might have some instabilities with too tight timers or other solutions. I personally like this. So this is basically our backbone network again, and looking at the metro regions, we've got data center handover routers in each data center. We've got heavily reduced routing tables, just because licenses cost a lot of capex, and they are not necessary. So we announce a heavily reduced routing table to those data center handovers, basically just a default route plus whatever internal prefixes for traffic engineering would be helpful. And because everything is in segment routing MPLS, we can use the data center handovers to connect different backbone regions. So for example, some of our locations in France are entirely connected through data center handovers without a direct connection to the backbone. So if we now take a look at the Baden metro region, Baden is basically a larger area in Germany. Looking at the downstream customers, what we try to do is give each downstream customer a block of private ASNs, which provides a clear demarcation point because we just have an eBGP adjacency to our downstream customers. And with a block of ASNs, we are free to use some data center spine design or whatever else. We just act as a central number registry within our company for those ASNs. Of course, some setups or some designs require iBGP to your downstream devices, which will lead to can lead to some problems. Especially sharing your IGP between multiple administrative regions can be problematic. So you of course need very strict policies, security measures to make sure nobody messes up, and you have a high risk of miscommunication. If somebody missets a metric and you haven't paid attention, you might lead to discarded traffic. Or for example, what could happen but totally didn't happen in production is that an engineer accidentally redistributes a link local prefix, which of course can't be routed into your IS-IS link state database. Some of your engineers in your team see this log message, which is on the right and in the middle, contact the team responsible for this, and this finally leads to the engineer trying to address the problem, leaking 200,000 internal prefixes into your link state database. Of course, didn't happen in production. Now, talking about aggregation, our downstreams announced some more specifics. The data center handovers originate metro aggregate routes. So each metro region has an iBGP full mesh, just so we can aggregate the metro region and not each individual data center. So we can move individual prefixes from one data center to another because renovation happens or something else. And those aggregate routes are then announced to the backbone routers, which send it to transit peering, PNI, PPI, whatever. For that, we're using announcements with latency-based MEDs, so we kind of pull traffic to the correct data center, and we use community-based filters. This is what our community setup basically looks like. So we can identify each ingress route from its origin, and egress, we can just say, hey, just announce every aggregate that happens to be our own IP space, and we're done. You might have noticed that we've got 15 sister companies and lots of history, and some of those companies have their own transit peering, whatever, and need a full table. We can't provide this in a data center because our data center handovers have a reduced routing table. So what we do is actually fairly simple, just announce all the internal routes they might need, plus some traffic engineering stuff to the downstream from the data center handover, and provide a eBGP multi-hop session from a couple closed backbone routers so they have a full table view. You have to be a bit careful with policies because you don't want to mess up your next hop, and you also don't want to mess up your internal routing, but it's a very stable setup and works fine. We also have a yearly hacker conference where we're kind of connecting every now and then, and they are connecting to the data center handovers as well. For this, we're just provisioning an EVPN VXLAN service because EVPN MPLS has a bit of a problem on our data center handover and a backbone router to backhaul the full table through a layer 2 service. So they don't see it's not directly connected, but they don't care as well. If we now take a look at the backbone network and talk about DDoS mitigation, if we have a look at the regular traffic flow, we can see that The regular traffic just ingresses from transit, peering, PNIs, whatever, through a backbone router, gets routed to a DC handover router and down to the downstream customers. And as you can see, the green router on the right, we've got a bunch of scrubbing routers in different locations, which when Anycast announce a most specific to draw traffic to them. Because of segment routing, this is another fairly nice thing. We can just the backbone routers will just stack a segment ID stack on top of each packet, which needs to go to the scrubbing router. So the data center handover doesn't need to know any more specifics and actually can't know the most specifics. So after the traffic has arrived at the scrubbing router, this is the scrubbing router is the only one that actually has multiple VRFs, which I think is pretty fun. The scrubbing router leaks it into a dirty VRF, forwards it to scrubbing servers, which then use just BPF and some flow sampling to determine which flow to clean. And they route it back to the scrubbing router, and when everything is finished, the scrubbing router pushes another segment ID stack onto the traffic to a data center handover router, and it just gets delivered as if nothing happened. So going dark. In this scenario, we're going to talk about a data center outage we had in Berlin, where we accidentally split our IS. So it's going to be it's going to be an interesting story. In this scenario, we have 3 POPs connecting the Berlin data centers, the Berlin metro area, and which is going to become slightly relevant. We've got 2 new bundles from Berlin to Frankfurt and Karlsruhe. This happened during the data center handover migration. So in this case, we're still announcing the aggregates on backbone routers, which is going to cause some problems later. Of course, Murphy's always watching, so the Amsterdam POP went offline. Fiber was cut. The Berlin-Frankfurt line was cut. So yeah, but we're fine. We still have the line to Karlsruhe, and due to bad weather, that line was also cut. Now we've got something I'd like to call a problem, because the data center is kind of disconnected from the rest of the network. We still have local transit and local peering, so the data center isn't completely offline. We still have partial reachability, but depending on where traffic ingresses the network, we are unreachable, because routers in Frankfurt, for example, are now announcing networks they can't reach anymore. So for peers we are not multi-homing with, we don't have multiple connections with, at some internet exchange where traffic just gets discarded. Because Berlin now has no access to internal networks with amplified impact, because provisioning services or internal DNS services might become unreachable, this might cause some problems with authentication servers or regular replication jobs, which of course isn't nice. Now, trying to get the network back together, this isn't really in IONOS network operator's control. We are basically completely helpless in this incident. This was escalated to a fiber carrier, and they weren't able to splice weren't able to fix the fibers. They can't be swapped to protected paths because the carrier just didn't have the capacity available. And in Frankfurt, technicians were on site, but yeah, whoever cut that fiber in Frankfurt also damaged the gas pipeline, and using a fusion splicer next to a gas leak, I don't know. As a last resort, we were evaluating GRE of our transit providers, because we theoretically had just enough unencrypted capacity available, and so we started identifying which traffic needed to be dropped to make this feasible. To patch the network back together, we started by withdrawing the black hole announcements, so to at least increase the percentage of traffic that would get delivered, and we started dropping certain VRFs which contained critical traffic, which we weren't able to route over transit providers. Now, after applying tunnel glue and finding out that GRE, the only feature I had trusted, wasn't actually working between two specific boxes, filtering the sensitive traffic between different data center locations, and holding onto our dear lives that transit wouldn't completely explode. Everything was at least halfway connected again. The fiber carrier came in clutch and spliced a new fiber or a new partial path in Frankfurt, connecting the data center again. Another fiber was rapidly spliced in Karlsruhe, so we're basically back to a redundant setup now. What was absolutely instrumental during this incident, which really rattled us engineers, was communication channels independent of IONOS, even though it hurts me personally that we're not self-hosting, for example, a Rocket Chat instance for internal communication. This using external services like Slack or Google Chat came in absolutely helpful, because, well, if your network isn't reachable, your chat also isn't reachable. Another thing that was really helpful is that engineers knew more than they had to. They didn't necessarily know each and every line of Nginx configuration the web hosting people were using, but just knowing which services had which requirements, so we didn't have to waste time on restoring services which wouldn't work anyway because they depended on a service which we can't restore. Management also did a great job not stressing the engineers about the problem, so we hadn't spent a lot of time worrying about what was going to come next, not working well into the night, or having to answer extremely difficult, unanswerable questions because management was interested in something. This was all abstracted away or not done. And of course, dozens of engineers at the fiber carrier and many colleagues helped. Now, what did we find out? This is a weather map of the specific day. Darker means more rain. Natural disasters basically took out all the available paths. So regular N+1 redundancy just isn't enough. We need at least two N+1 redundancy, and we need to go through different cardinal directions because most of the lines were going through West Germany and the entire region was flooded. You also can't count on your AS staying physically connected. This was something I personally never considered, because why would you separate your AS? So we moved the aggregates, established last resort backup paths with incredibly high metrics just in case, and this incident really showed that even the most well-known and tried and tested technologies can still have some problems. Murphy is watching at all times, so you have to really have a backup plan for your backup plan and test everything 60 times. Knowing how the network is used is also very interesting, because it helped kind of define the requirements without having to talk to other people. We could just say, okay, this is an enterprise environment. You might need these and these services. Hey, you've got this replication job. Could you maybe stop it for a moment so we don't run into capacity issues? And sometimes you provide add-on features like the MACSEC encryption on your lines, and people start depending on those features. If you don't know about this and you have to disable that feature in a situation of distress, you might cause other problems. So knowing how your services are used and which features, even if they're just extremely minute, are used is very helpful. So now we decided that each data center has to have at least 3 lines leaving each location. So usually it's not possible to get more than 2 house entries in a data center. So we can reuse or we have to use the same house entry, but have the lines diverge as soon as possible, just so to reduce the area of potential interference. And yeah, of course, all lines are encrypted just because. Yeah. Each metro region then uses OTUC2 and OTUC4, so OTN transport for the optical transport. It's extremely flexible and helps with encryption, helps with providing different services using WDM shelves as breakout line cards, for example, for smaller locations, so you don't have to place a router. Is very helpful, and we encrypt everything on either on the WDM shelf or on the router directly. So this is what it looks like now. We've got basically we've got 4 fibers leaving in 3 different cardinal directions. So if a storm like that happens again, we're at least held together through Poland. We've got a partial mesh of tunnels with automatic load shedding, and yeah. Talking about interoperability services, we've kind of experienced some problems, so I'd like to warn other engineers. This really shows how important testing is, because we didn't really think this would be an issue in our lab. Provisioning an EVPN service between two through a Juniper PTX router works without any problems for unicast, multicast, and broadcast traffic. But as soon as the traffic is encapsulated with MPLS, you might experience a bit of traffic loss. This is known to Juniper and will be fixed in a future version. But just as a heads up, because this actually caused quite a bit of impact when we provisioned services. Of course, the IGP adjacency, LDP, or whatever else the customer is using works without any problems, but as soon as MPLS traffic passes through your backbone device, it's lost. And another side note, with MACSEC encryption, there's a field called the SCI, which is theoretically just unnecessary overhead to the packets. Some vendors disable it per default, others have it enabled. So for interoperability, it usually helps to enable it, because many vendors have it enabled per default. And yeah, after showing you those data center Gore pictures at the beginning of the presentation, I'd like to end with something a little bit nicer, and hope you won't throw stones at me.
Hey, thank you, David. And I do agree that is a much nicer picture, because it's beautiful yellow. There's no aqua, there's no orange. Okay, I'm a single mode snob. Are there any questions for David? Anybody want to come up to the mic with a question for David? I thought this was really good, by the way. I used to run big networks. I don't do that anymore, and I understand what he did. Yes, sir.
Adam Kujaski with Ohio IX. When you were pegging up the emergency tunnels, did you have any MTU issues, or were you already kind of ready to go with jumbo frames supported with your IP transits? Did you have to like reset MSS to a smaller value? Any other things?
We didn't have any MTU issues. So that tunnel had, because we had the interop bug, that tunnel had to go through 2 different tier 1 providers. We have jumbo frames enabled on both of them, but weren't sure if they had jumbo frames enabled to each other. And Murphy was apparently very gracious that day, because we weren't able to get jumbo frames through, but an MTU of 3,500. So, but yeah.
All right, thanks.
Okay. Jeff, Kate, anything from the outside world?
Jeff Haas, Juniper. Please do not personally blame me for any of the bugs you're seeing. So I may miss this during your talk. When your AS got partitioned, did you do any repair of that using the loops command to route it through other service providers? Sorry if I missed that.
Could you repeat your question, please?
You said you had an AS partition. You couldn't have your different pieces of your AS talk to each other. Did you repair them through other service providers as part of this exercise?
No.
Okay.
Our friend the loops command.
No.
Our friend the loops command. Something that occurred to me as we were working through this is we have these wonderful BGP security things that are becoming very important to people. And this is a scenario that might be tricky in that circumstance.
Yes.
Thank you.
Next, please.
Hi, Tom Sullivan, Jane Street. Just wondering, your note about Junos Evolved and EVPN, was that PTX specific or was that platform independent?
So right now we're only using the Juniper PTX 10004. I don't think it happens on the ACX series with Junos Evo.
Okay.
It's I think it's just an Express thing,
Yeah.
but it's already fixed in a later Junos release. I'll have to get the exact number, but if you're interested, I can get it for you.
Okay, thank you very much.
Oh, and I can answer that. The ACX does support it.
Oh.
I've done it.
Yeah.
Anybody else? Going once? Going twice? David, thank you. You are no longer a first-time presenter. Please come back.